So, have you ever really stopped to wonder how an AI model goes from knowing basically nothing to making these mind blowing predictions? Well, today we're popping the hood and looking at gradient descent. This is the core engine, the absolute heart of how AI actually learns. Let's dive in. I mean, that's the big question, isn't it? We hear AI is learning all the time, but what does that even mean? What does it look like? Well, I'll tell you. It's not some kind of magic. It's actually a really clever mathematical process, and it's designed to solve one very, very specific problem. Okay, but that brings up a good point. If it's all just math, why can't we just, I don't know, calculate the perfect answer right from the get-go? Why do we need all this training and learning business? The reason, in a word, is complexity. The sheer, almost unbelievable complexity of the problems AI is trying to crack. And that gets us to the absolute core challenge of AI learning. It's all about minimizing error. You see, when we say an AI is learning, what it's really doing is trying to find the single point where its answers are the least wrong. The problem is, the scale of that challenge is just too massive for our usual methods. Think about it this way. If you have a simple curve, like a parabola you remember from high school math class, finding its lowest point is super easy. You can do some quick calculus, and boom, you've got your answer. But an AI model's error function, whoa, that is a completely different beast. And here's exactly why. We're not talking about a function with one or two variables. We're talking about functions with millions of them. Trying to solve for the one perfect combination of all those millions of variables at the same time, it's pretty much computationally impossible. So we need a smarter way to go about it, a more step-by-step approach. And that smarter approach, it has this perfect analogy that makes the whole thing just click. It's called the blind hiker's solution. Okay, so picture this. You're standing somewhere on this massive, sprawling mountain range. And just to make things interesting, a super thick fog rolls in. You can't see anything more than a few feet in front of you. No map, no compass, nothing. Your goal is simple. You need to get to the very bottom of the valley. For our AI model, this is that point of lowest error. But how on earth do you find it when you can't see the whole landscape? And this is the brilliant intuitive solution. You might not be able to see the bottom of the valley, but you can feel the ground right where you're standing. You can feel which way the slope is steepest, which way is down. So what do? You take one step in that direction. And then you do it again. You feel the ground, find the steepest way down, and take another step. Over and over and over. That simple strategy our hiker is using, well, that's the exact same logic that powers gradient descent. So let's see how we translate that idea from a mountain into a little bit of math. So that feeling of the steepest slope under the hiker's feet, in the world of math, we call that the gradient. You don't have to be a calculus whiz. All you need to know is that the gradient is basically a little arrow that always points in the direction of the steepest downhill from wherever you are. And here you can see that whole journey in action. The process starts at some random spot high up on the curve. At that exact point, it calculates the gradient, which way is down, and it takes a step. Each one of those dots is another step, getting closer and closer, until it finally lands right at the bottom, the point of lowest error. So, this entire powerful algorithm really just boils down to these four simple steps. 1. You start with a totally random guess. 2. You calculate the gradient to figure out which way is down. 3. You take a small step in that downhill direction. And 4. You just repeat that process until you can't go any lower. That's it. And if you want to see what that looks like as an equation, it's actually pretty straightforward. Your new, slightly better guess is just your old guess minus a little bit of the gradient. And that minus sign, that's super important. It's what makes sure we're always moving down the slope, not accidentally climbing back up. Now we've got to talk about that little alpha symbol in the equation. Because how big of a step you take, well, that might just be the most important and trickiest part of this whole thing. It really is an art. That alpha is what we call the learning rate. It's basically a knob that data scientists get to tune, and it controls the size of every single downhill step. If you get it right, your model learns efficiently. If you get it wrong, well, things can get messy pretty fast. And you can see the three possible outcomes right here. Because it's not just about going downhill, it's about how you get there. Let's look at what happens when that step size is wrong versus when it's just right. So first, what happens if your learning rate is too low? Well, that's like our hiker taking these tiny, shuffling baby steps.
Yeah, you'll get to the bottom eventually, but it's going to take forever and use a ton of computing power. It's safe, but it's definitely not efficient.
Then you've got the Goldilocks scenario, where the learning rate is just right. The steps are confident, they're decisive, moving quickly down the curve, and hitting that minimum point without wasting any time. This is the sweet spot. This is what every machine learning engineer is aiming for.
But if your learning rate is too high, you just get chaos. This is like the hiker taking these giant, reckless leaps down the mountain. They'll jump right over the bottom of the valley and land on the other side, sometimes even higher up than where they started. The model's error just bounces around all over the place, and it never actually finds the solution. So, when you put this all together, this incredibly simple idea of just walking downhill, well, that becomes the powerful, fundamental engine that drives pretty much all of modern artificial intelligence. All right, so let's just recap the big takeaways here. Gradient descent is a step-by-step process that's all about minimizing error. It uses the gradient to find the fastest way downhill. The learning rate is that critical knob that controls the size of each step. And this whole thing? It's the fundamental way that AI models actually learn from data. And that leaves us with a really fascinating thought. This simple, elegant idea, just finding the lowest point in a really complex landscape, is what's powering AI today. So you have to wonder, what other huge, complicated problems could we solve just by figuring out which way is down and taking a step?